Just looking at some properties of playing with the conjugates. So some of these we've seen already. Some of these will just make sense. The first one's one of those. The modulus of a complex number must be the same as the modulus of its conjugate. We saw that were reflections in the x-axis, things like that, but they've got to be the same distance away from the origin. And again, talking about reflection, that means their arguments, well, the angle it makes with the x-axis would be the same, but one's going to be above the x-axis, one's going to be below. So the argument of z is minus the argument of the conjugate. That's what we've talked about, z conjugate. Before we said it was x squared plus y squared, but now we can simply say, oh, well, it's the modulus squared. And we talked about these rules before. The actual order you do it in doesn't matter. You can add them first, then find the conjugate, or find the conjugates, then add. Same with multiplication, same with division, and our reciprocal. So now we can say, oh, well, the reciprocal is just the conjugate over the modulus squared. Here's a question. You can do it in different ways, but I'm going to solve this problem using conjugates, purely using the conjugates idea. So we're told that x plus iy is the square root of this expression. We need to show that the real part squared plus the imaginary part squared is 2. Okay. So they've told me x plus iy is that expression there. So if I was to square both sides, then I'd get x plus iy squared is 6 plus 2i on 3 minus I. But I can play with the conjugates now. The conjugate of both sides must be equal. Well, the conjugate of the division, we said, was we could do it in any order. So I could rewrite that as conjugate of 6 plus I on conjugate of 3 minus I. All right, now I've got these two expressions. If I multiply them together, the left-hand side we now get difference of two squares squared. And on the right-hand side, each of those fractions is also difference of two squares. So on the left-hand side, I get x squared plus y squared squared. And on the right-hand side, I'll get 36 plus 4 or 9 plus 1, which is 4. So therefore, x squared plus y squared must equal 2. And notice it's not plus or minus 2, because we're saying two real numbers squared. There's no way that could be a negative answer. So it's only going to be 2, and that's what we wanted to show. Okay, so that was a quick one. Our text doesn't really have an exercise on this, so I grabbed one out of the old Patel book. It was just playing around with the complex conjugates there.